So now we're going to look at an example of graph transformations. So the diagram shows the graph of y equals g of x. So this is g of x here. This is this function. And we're asked to sketch the graph of y equals negative g of x. Okay, so we're going to do it on the same graph here. So negative g of x, what's this going to mean? Well, this negative sign is outside of this x bracket here, so it's only going to affect the y coordinates. So let's have a think about the y coordinates are going to change. Well, these are all going to stay the same. The point is 0 because 0 negative of 0 is still 0. Okay, so these are all going to be the same. And what about this point here, a negative 1? Well, since it's the y coordinates, it's only going to affect this negative 1 here. So this negative 1 actually goes to positive 1, right, up here. So this point becomes a, because the x coordinate remains unchanged, negative 1, right? So that's our new point. What about this point here? Well, again, the x coordinate is going to remain unchanged. It's still going to be 0, but instead of being positive 1, it's going to be down here at negative 1, because you're taking the minus value of that y. So it's 0, negative 1. And what about this point here? Well, you've got b4. So again, it's going to be b, but it's going to be down here at negative 4. So b, negative 4. So your graph's going to look like this. Well, this was coming from above, so this is going to come from below. And he's going to follow the points through all the way down to there, then up there. Perfect. So it's just a mirror image of this graph here along the x-axis. What about this part here? So on the same diagram, sketch the graph of y equals 3x minus g. Okay, so what's happened now is we've got this 3 term. So you could rewrite this as saying y is equal to minus gx, which we've just worked out, plus 3, because you can move this 3 over there, and this becomes plus 3. This means exactly the same thing. So what this really means is, okay, we're still thinking about the y coordinates here, because there's nothing affecting inside this bracket. So what's this going to happen is we're going to add 3 to every y coordinate. So what's going to happen here? Well, here we've got this is going to be a negative 1, but instead if you add 3 to that, sorry, that should be a positive, shouldn't it? My apologies. A positive 1, this is actually going to go up to 4 here. So this is going to become a4. Okay. And this this negative 1 here is gonna, so this was 0, negative 1 from the negative g of x. When you add 3 to that, it's actually going to go negative 1 plus 3 is 2. So this is going to go here as 0, 2. What about this point here? Well, this has been flipped down to negative 4. Negative 4 plus 3 is actually just going to be negative 1. So that here. Again, this isn't exactly to scale. If you were on graph paper, it would be. But as long as you label your points correctly, then you'll still get all your marks. Okay, so now we need to complete the drawing of this one. Okay, so it's going to come up like the negative g of x, but instead of going to 1, it's going to go to 4, down to 0, 2, all, okay, draw this a bit better, up to there, down to there, down to negative 1, then up and out. Okay, so graphs are y equals negative g of x and y equals 3 negative g x. So the next example. The diagram shows the graph of y equals f of x. So this is here, this is y equals f of x. F of x has a minimum turning point at 0, negative 4 here, and has a point of inflection at negative 6, 2. So in here, negative 6, 2. Sketch the graph of y equals f of minus x. Okay, so before we were looking at minus f of x, now we're looking at f of minus x. So this minus is inside the brackets. So what's this going to do? Well, this, because inside the brackets here, it's going to affect the x coordinates. Those are what are going to change. So first off, this point here is on 0, and if you take 0, negative of 0, it's just going to be exactly the same. So this point stays the same. But what about this point, negative 6 here? Well, negative 6 is going to go from negative 6 to positive 6 over here. 6. This point here, negative 3, is going to go to positive 3 here. 3. This point here, 1, is going to go to negative 1 here. Negative 1. Okay. But the y points, the y values, they're going to stay exactly the same. So this 2, positive 2 here is still going to be a positive 2 over here. Okay? So again, this is going to have like a mirror in the y-axis, right? Or the f of x axis. So what's going to happen now is it's going to go down through here all the way to the minimum, then along to this point here, then to the point of inflection there, then up. So it's obviously not perfectly drawn, but you can see here that this is just the mirror image of what happened on the other side over here. Okay? So, next part. Now we're asked to sketch, on the same diagram, sketch the graph of y equals 2f of minus x. So this 2 is like the k factor. So this is y equals k f of x. That's minus x. So this k factor means what we're going to do, you're going to be stretching it out by 2. So all the y values are going to be twice as big. Okay. So let's have a think about here what's going to change. It's still going to be the minus x, so it's expanding the one we have. So the y value 2 times 0 is 0. Okay, and 3 times 0 is also 0. Okay, and then before, one sec, I'll put this in to make it clear. So we had 6, 2, and we had 4, 0. Oh, that's the wrong way around. 0, 4. Okay, so what's going to happen now? If everything's multiplied by 2, well, this is going to go down to negative 8, 0. So let me put it over to the side. 0, negative 8, because that is twice the size of negative 4. This is down here. And what about here? We're going to go from 6, 2 to what's twice of the y value? Well, twice the y value is 4. So this is going to become about there. This is going to become 6, 4, right? That's going to be our new value. So it's going to come through just as before, down here, through the blue marker, but instead of going all down to 4, it's going to go all the way down to 8. Then again, it's going to come back up through here, but instead of going to the 6, 2 point of inflection, it's to the 4, 6, 4 point of inflection. There it is there. So you can kind of, like, again, it's not to scale, but what's happened is this has been stretched, and then this has been stretched as well. I hope that gives you an idea of the graph transformation questions. It's really, like I said, have a go at Desmos, play about with, type in different ones and see how they change, and that gives you like a really good idea of what's going on.